Okay, part 2 of the midterm, which, by the way, you need a calculator for, which, by the way, you cannot share calculators, and you cannot use a cell phone to double as a calculator. You need either a standard issue TI Smart Calculator, a TI Stupid Calculator, or the communist Casio. Okay? I feel like a commercial, like this program is being brought to you by TI and Casio. Anyway, okay, I want you guys to really pay attention to numbers 69 through 76 because when we get to a different variation of those problems, I'm going to refer back to them. So let's take a look at number 70. Number 70 says 5 to the x equals 120, or the square root of 125. Okay, now, the square root of 125 is the same thing as saying 5 to the x equals 125 to the 1/2 power. Does that make sense, everyone? Can we all agree with that? Okay, now, with these problems, you have to first identify, do they have a potential common base? Do 5 and 125 have a potential common base? Carter, what do you think? Yeah, which is what? 5, right? So I could say 5 to the x is equal to 125, which is really 5 to the 3rd raised to the 1/2. And now I can use my laws of exponents to multiply 3 times 1/2 to get 5 to the 3 over 2 equals 5 to the x. And now that I have the same bases, what can we conclude that x equals? Luke 1. 3/2. X equals 3/2. Very good. Okay, let's do something a little harder than that. Let's do something like number 72. Okay, it reads 6 to the x plus 1 is equal to 36 to the 2, oh, just kidding, that's kind of where I want to go with it, to the x minus 1. Alright, so again, get the bases to be the same. So 6 to the x plus 1 is equal to 6 squared to the x minus 1. So here we have x plus 1 equals, I'm going to replace and distribute all at once, so 2x minus 2. So I subtract x from both sides, and then I add 2 to both sides. So all that goes away, so I get x equals 3. Alright, that's one of the harder ones in that section. Okay. Let's evaluate each logarithm. Let's do a few of these. So 77 through 84. Let's say something like number 77. Log base 2 of 64. Now, because 2 and 64 kind of have something similar, they're really asking you 2 to the what power equals 64. What is the answer to 2? That one you kind of just have to know. If you don't, then you better start learning your exponents of 2. Daniel, what do you think, buddy? X equals 6. So you just put a 6 right here, and you're all done. The ways they can make it harder might be to give you something like number 79. They might say, hey, log base 2 of 1/8 equals something. Okay. And that is supposed to be a 2, not an equal sign. Okay, so that means 2 to the something equals 1/8. Now, there is only one type of number that will turn a whole number into a fraction, or at least a coherent fraction, when you raise it to an exponent. What type of number is that, Luke? It's got to be a negative number, right? And then we just got to figure out 2 to what power equals 8. Daniel? Negative, in this case, negative 3. Very good. Does that make sense, everyone? You just have to kind of think your way through it. It's like, okay, what's the only way I can get a coherent fraction in here? Got to be a negative. And then 2 to the 3rd, boom. How about something like number 81? Log base 36 of 6 equals something. So they're saying 36 to a certain type of power is going to get you 6. Now, there's only one type of number that will take a big number and make it smaller. There's only one type of exponent that does this. What type of exponent makes a number smaller? Daniel? A type of fraction. So, 36 to what fractional power is equal to 6? Luke 1. 1/2. Oops. That's as far as you need to go with this problem. Okay? One thing that I want you guys to keep in mind is something like number 83, log base 5 of negative 25. What is that outright? That one should be the easiest problem in the entire packet. Carter? No solution, because there's nothing you can raise 5 to that's going to get you a negative number. It does not exist. Okay? It does not exist. We do not acknowledge it. Okay. Let's take a look at something like number 89. Log base 5 of x minus 1 squared equals log base 5 of 1. Now, we have a single logarithm of the same base on both sides. Because we have a single logarithm of the same base on both sides, what can we do with those logarithms, Ayush? We can cancel them out. And it's because we have a single logarithm of the same base on both sides. How do I solve for x this time? How do I get x by itself? Carter, what do you think? Why not? So we get x minus 1 equals plus or minus 1, and then we add 1 to both sides. So I got x equals 2 or 0. Now, because we had x's in the answer component, we have to go back and check. Which one of these works, which one of them doesn't work, if any? Carter? Anything squared is positive, so they both work. 2 minus 1 is 1, squared is 1. 0 minus 1 is negative 1, but we end up with a problem. There's a negative, however, it's being squared, so we're all good. So both answers work. Please make sure if one of them doesn't work, you exclude it visually. You at least have to show me you considered the answer. Okay? All right. Let's take a look at something like number 94. Log base 2 of x plus log base 2 of x minus 2 equals log base 2 of 3. Guys, what's the most common wrong transitionary move that I'm going to see in this problem? Angel? Cancel out the logs right away. People are going to say, oh yeah, 2x minus 2 equals 3. X equals 5 halves. Woohoo, done. Checked it, it's all good. That is wrong. What do you need to do first with this problem? What is the correct first maneuver in this problem? Trevor? Combine the logs. Now, they're both being added, which means the answer components are being what? AJ? Multiplied. So I put a single log base 2 of x parentheses x minus 2 equals a single log base 2 of 3. Now that I have a single logarithm on both sides of the equal sign, only now, under those conditions, can they do what? Chris? Now they can cancel. They're the same base and there's a single log on both sides. So x squared minus 2x equals 3. So x squared minus 2x minus 3 equals 0. Factor it out. X looks like minus 3x plus 1. X equals 3 and negative 1. Now, because there was an x in the answer component, what do we need to do? Which one of these works? Which one of them doesn't? Luke 1. This time negative 1 does not work because we're not going to square anything, so we're done with it. But make sure you show me that you considered the answer. Da? That means yes in Russian? Okay. Let's do one that requires us to do something a little crazy here. How about something like number 100? Log base 6 of x squared plus 2 plus log base 6 of 2 equals 2. Okay. Again, we are going to combine our logarithms. They're being added, which means they're being multiplied on the answer component. So log base 6 of 2 times x squared plus 2 equals 2. Now, there's no logarithm on the right side to cancel. There ain't one. So we're stuck at this point. When we're stuck, how do we get ourselves unstuck from a logarithm? Trevor, what do you think, buddy? Change forms. So 6 is the base, 2 is the exponent, this 2 right here is the exponent, equals 2 parentheses x squared plus 2. So we got 36 equals 2 parentheses x squared plus 2. Now I'm going to solve this a little weird just to give you guys a little run for your money here. I'm going to divide both sides by 2. 18 is equal to x squared plus 2. X squared equals 16. X equals plus or minus 4. Check it because it doesn't, because we have an x in the answer component. So which one works, which one doesn't? Stephanie! Which one works, which one doesn't? Stephanie. Both of them work. Stephanie, why? Because you're going to eventually square the negative 4. Stephanie! Good job. All right. You know, I'm going to go and pass over 104 through 115, kind of, because that's just calculator work. However, I am going to do problems like number 112 through 115. So let's take a look at 115. It says use a calculator to approximate the value round to 3 decimal places. Now, this problem here is log base 6 of 47. Now, some people are like, wait a second, I just have a stupid TI calculator. I don't think my calculator can handle base 6. You're right, it can't. I think the communist Casios can handle different bases, though. Now, even if you have the communist Casio calculator, you have to show me the work. If you have to show me that you understand change of base formula. Does anyone remember seeing something that looked like this? Okay, you have to do that, and then from there you go ahead and do your decimals. Okay, you have to show me this to get full credit. If you don't show me this, you ain't getting squat. Okay, so make sure you guys know to show me that work. All right? Okay. AJ, what's up, buddy? Oh, okay. Oh, no problem. We can do that. So let's take a look at number, say, 106. So anti-log of negative 1.543. All right, AJ, all this thing is asking you to do, since it's anti-log, it's asking you to say, in your calculator, take 10 and raise it to the negative 1.543 power. That's all it's asking you to do. Okay? And then if you see something like anti-ln, so like if we look at number 111, anti-ln of 2.468. Remember, AJ, natural logs have a base of e. So it's just saying e to the 2.468 power. And that's it. It's just calculator after that. Okay. Let's move on to wearing the big boy pants. 116 through 127. Now, remember, I told you guys I was going to refer back to those base problems. Let's look at something like number 116. 6 to the x equals 12. Now, compare that to number 70. Now remember, in number 70, 125 and 5 had a potential common base. Remember I said that? We said that. You can rewind it and you'll see it. 6 and 12 have no common base that can be raised to an exponent. Yes? Do we agree with that? I can't raise 6 to anything to get 12, yeah? Can't. So, when that happens, when you run into a situation like number 116, you have to take either the log or the natural log of both sides. You have no other option but to do it. So it's going to be ln of 6 to the x equals ln of 12. From here, the x is going to drop down. You get x ln 6 equals ln 12. And remember, what is the natural log of 6? Carter, what's the natural log of 6? A number. So you get x times a number equals another number. How do you get x by itself? You divide by the number. So x equals ln 12 over ln 6. Remember, this is your calculator-ready form, which you need to get most of your credit. What is the most common wrong answer that I am about to see next? AJ. natural log of 2. That's wrong. You've got to take them individually and then do the answer. Okay? So that's how you do 116. Let's take a look at something else. Move pages here. Okay, let's take a look at a really evil kind of problem like number 121. 3 to the 2x is equal to 5 to the 4x plus 2. Okay. Let's take the natural log of both sides. That's a no-brainer. So I get 2x ln 3 is equal to, 4x plus 2 ln 5. Now, I have no choice. I have to distribute this thing. So I get 4x ln 5 plus 2 ln 5 equals 2x ln 3. Now, at this point, the operations become basic. Move all the x's to one side, factor out an x, divide by the big thing. That's all you do all the time. Move all the x's to one side, factor out an x, divide by the big thing. So what am I going to do? I'm going to move all the x's to one side. So I got 2x ln 3 minus 4x ln 5 equals 2 ln 5. Now, I'm going to factor out an x. That leaves me on the inside with 2 ln 3 minus 4 ln 5 equals 2 ln 5. Now, I said we were going to do it. We're going to do it. We're going to divide by the big thing. This right here is your calculator ready answer. Your calculator after answer will be the decimal, but make sure you show me all the way through here before you start crunching numbers into your TI calculator or your communist Casio calculator. Right, Luke One? All right. Okay. 127 through 136 is the word problems. Hey, by the way, I might want to just throw that formula on your quiz tomorrow too. What is that formula that we need to solve all these exponential problems? Who in here cleans their hair on a daily basis? Lukman. A equals P to the RT. PERT formula, right? As long as you wash your hair at least once a week, you should know this. Okay. Let's do a couple of these types of problems here. Let's say here, number 130. Alyssa deposits $15.50 into an account where the interest is compounded continuously. The interest rate on the account is 7.25%. How much money will Alyssa have after 8 years? Okay. We got to identify all of our parts here. Okay, Alyssa deposits $15.50 into an account. Now, what role does $15.50 play in this whole problem? If she deposited $15.50, AJ? P, it's the initial, the principal amount. That's how much she started out with. Into it. Okay. The interest rate is 7.25%. Where does that go, and what does that number actually become? Matthew? $0.0725. Awesome, right? Not 0.725. That's 72.5% interest, and while that's pretty killer, unfortunately, it's just not reality. At least not in my lifetime, anyways. How much money will Alyssa have after 8 years? What role does 8 play in all this? Trevor? T. And then what's E? E. And then what's A? That's what we're trying to find out. So now it's going to be A equals. Now we rarely run into problems like this where everything's isolated on one side. It's 1550 E to the 0.0725 times 8. Now, here's how you do it in a stupid TI calculator. You have to do 0.0725 times 8, enter. Second ln, enter. Times 1550, enter. If you have the Smart TI or the Communist Casio, you have parentheses. Okay? So, take a second and figure it out. I will do the same. Raise your hand if you got, Luke 1, what'd you get? 2,768.85. Let's say 3, 6, since we're dealing with money. Okay? Raise your hands if you got 2768.36 as your dollar amount. Awesome. Very cool. Let's do another one. This is the last problem. I'm going to erase the PERT form. Oh, Matthew, what's up, buddy? Sorry. Okay, so let me see your calculator real quick. You have a Smart TI. Okay, so actually, no, I'm sorry. You have a halfway Smart TI. Yours is a complicated Smart TI. I'll show you how to do it afterwards, okay? Hey, John, what kind of calculator do you have? No, just stay it like that. Yeah. No, okay, no, John, because that's how much money she will actually have. The amount of that's not money. That's not how much money she accrued. That would be awesome, right? But that's how much money she will have. Hannah, what's up? Okay, so if you look at the problem, it says the interest rate on the account is 7.25%. You see that? Okay, so anytime you're dealing with percents, Hannah, like if I say 7.25%, what that means as a decimal is 0.0725. You always move the decimal place over twice. Right? So if a rate, let's say I gave you a problem on the midterm, the rate was 2.19%, then your decimal would be 0.0219, right? Because it's always two decimal places to the left. Okay, so let's do the last one, a half-life problem. Let's take a look at something like 131. A substance composes radioactively. Its half-life is 32 years. Blah, find the decay constant. Okay. Half-life is 32 years. 32 years is obviously T. We're trying to find the decay constant. That's the rate. We have no idea what it is. E is E. Now, with all half-life problems, they never give us A and P. However, how do we find A and P? We have to come up with those on our own. 70! How do I do that? Stephanie, give me a number. 10. Okay, that's how much we're going to start out with, right? So, Stephanie, after 32 years, how many particles of radiation am I going to have? Stephanie. Good job. Okay, let's take a look at what this looks like. 5 equals 10. E to the 32R. 0.5 equals E to the 32R. Take the ln of both sides. ln of 0.5 is equal to, hey, what happens to the ln and the E? Angel, they're gone. So, the biggest mistake that I tend to see on quizzes is this. They forget that. Okay? So, make sure you're not one of those people who forgets that. It's ln of 0.5. So now we got to do this in our calculator. We're going to divide both sides by 32 to get the answer. ln of 0.5 divided by 32. R is approximately equal to 0.0217, and it's negative. Now, why in blazes would the rate be negative? What's that all about? Angel. It's decaying. So yeah, the rate's got to be negative. It's breaking down. All right? There you go, people. That's one of each type of problem from chapters 8, or the latter half of chapter 8, chapter 9, and chapter 10. We will take care of one of each type of chapter 11 problem tomorrow.